Okay, Matrix, so welcome back to this advanced class. This unfortunately is going to be the last one that we have in this section. I've got two questions that I want to do with you tonight. This one that I've just started now, I want to finish because the next couple of questions are definitely really difficult. And then I've got another question that is also difficult that I want to do with you as well. All right, so I'm having a quick look at names here, and I'm hoping that everybody that's in this class was in the previous class. All right, so some people's names I recognize, other people I might not have seen. Okay, so everybody that's with us now, were you here with us in the previous class this evening? So in other words, in the class from 5 to 6 where I had done the first part of this question.
Just give us a thumbs up or a thumbs down.
Give us a yes or a thumbs down, a yes or a no. Yes, 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 yes. Okay, excellent. Oh, it's so nice you guys all came back. Are you enjoying your lessons with Watobe? We hope so. Nice. Okay, so now that we know that, let's not waste cool. We love teaching. So, and you guys are amazing. Thank you so much for your questions and the way you interact with us. We absolutely love it. Coco and I in our element. Okay, so let's continue with this question and let's get it sorted out. The next couple of questions are going to be difficult. All right, well, mind you, what we've already just done in part A, that's also considered difficult because we don't know in which two triangles that we need to work. So the fact that we've been able to do that is already a good thing. All right, so we've been able to prove that PA squared is equal to PC times PT, and that's because triangle PAT and PCA were similar to one another. Now we're going to turn our attention to the next question. All right, so here they want us to prove, Matrix, that PT is a tangent to the circle. Okay, so when they ask us to prove that a line is a tangent to a circle, just like when we saw the word tangent, we said tan-chord theorem. If we have to prove that a line is a tangent to a circle, how do we do that? What do we use? Does anybody know?
Tangent theorems. Yes,
Nyeko, you're on the right track. Nakutaba, what were you going to say?
I just want to say the converse tan-chord theorem.
That's it. That's it. Okay, so yeah, 100%. Converse tan-chord theorem. Brilliant. All right, so now that we know what we're going to use, we know what we need to go and look for. I don't know if me highlighting this has made it easier to read or more difficult. I think I'm just going to take that off. Okay, so PT is a tangent to the circle. We're going to do that by proving converse tan-chord theorem. All right, so now we're going to go back and we're going to look at our diagram, and we can see that line PT, so I'm just going to rub this out. Come on. Okay, line PT is over here. All right, is a tangent to circle ADT. So here's A, there's D, there's T. All right, so this circle is not drawn, okay, but it kind of looks something, kind of, like that. It's not the best circle I've ever drawn, but I suppose it's not the worst. Okay, so this circle is not drawn for us. So now, in order to prove that PT is a tangent to this circle, what does that really mean in terms of which two angles do we need to prove are equal to one another? Does anybody know?
Ma'am, can you say T4 and A1?
Who's talking?
It's Kayla, ma'am.
Kayla, you are amazing. That is wonderful. How did you see that? How did you know where to look?
I looked at basically like the side that it touches, and then I went into the corner, like I finished it with my fingers, if you get what I mean.
Absolutely.
So I saw
Kayla,
that T4 was on the side of TD.
absolutely. I'm so pleased, Kayla. That really makes me so very, very happy. I hope the rest of you that are with us this evening were able to see what Kayla has seen. All right, so if line PT is the tangent to the circle, that means that this angle over here, T4, would be the angle between the would-be tangent, TP, and the chord. Okay, so TD is the chord. All right, and then you're going to do what Kayla said. You're going to put your finger at T, you're going to put your finger at D, and then you're going to go to the circle. All right, so when you follow T to the circle and you follow D to the circle, they're both going to A. You can see that we need to prove that angle A1 is equal to angle T4. All right, Kayla, that was amazing. I'm so pleased. Well done. All right, so i.e., that means we are proving angle T4 is equal to angle A1. Right, now, if you recall from the previous question, what is A1 already equal to?
To C1.
C1, absolutely, to C1. Okay, remember we did it over here. Okay, so tan chord theorem. All right, so we know that A1 is equal to C1. Is there anything else that A1 would be equal to, or C1 would be equal to in this particular case?
MC3.
C3? I don't see a C3.
T3, man.
Oh, T3. Okay, all right. So T3 and T4 are equal to one another. Fair enough, because they're vertically opposite. I quite agree. All right. Is there any way that we can relate?
Ma'am, can't we say that C1 equals T3 because of alternate angles?
Can't we say that C1 equals T3 because of alternate angles? Because we also knew in the beginning, unfortunately I've rubbed them off here, that BT and AC were parallel to one another. Absolutely. Okay, so you guys have now found the link between the two. Okay, well done. So we know, we'll just go through it again. We know from similarity, or no, actually it's not similarity. We know from tan chord theorem that A1 equals C1. We know from parallel lines that C1 equals T3 because they are alternate. And T3 and T4 are equal to one another because they are vertically opposite. Okay, so that means that T4 and A1 are equal. Now we have to put that down on paper. Okay, so this is how we're going to do it. All right, well done, Matrix. This is great. Angle A1 equals angle C1. Because we've already done it over here, we could say proved above, but we could say tan chord theorem as well if we wanted to. Then we're going to conclude that C1 is equal to T3 because they are alternate angles. And that is because BT is parallel to CA. And then we're going to say, well, T3 is equal to T4 because they are vertically opposite angles. And now we can conclude if all of these angles are equal to one another, then the one where we started and the one where we are ending have to be equal as well. Okay, so that means, therefore, those two are equal. So that is the reason why PT is a tangent. And as you had correctly said in the beginning, I think it was Nokutaba who said this, we're going to use converse tan chord theorem. Okay, well done. I'm really, really pleased. That's excellent. That was a difficult question. Okay, nice one, Matrix. All right, you guys ready to move on?
Yes.
Okay.
Yes,
So let's
ma'am.
just, okie dokes. All right, so let's just move this over just a wee tiny bit. All right, so there's something in the chat here. Thelma's got a thumbs up. Good, Thelma. We like to see thumbs ups. Even if you're not happy, you can still tell us, and then we'll try and fix the problem, whatever it is. All right, so we've proved that PT is a tangent to circle ADT. Now things start to get really interesting. All right, so here in question C matrix, all right, they want us to prove that 9dt times dB equals 4pt times pc. Isn't that bizarre? Okay, that's why I actually picked this question, is because of this. So 9dt times dB is 4pt times pc if AD equals 2/3 AP. All right, so now let's go back to the diagram and let's try and fit in this piece of information over here. All right, now somebody asked a question. Okay, oh, so Tandalwetu, you're saying, okay, you're saying that A3 equals T3, absolutely, because they are angles in the same segment, but is that going to help us with question C? Not sure that it is. All right, let's go and have a look at what they're telling us. So here they say to us that AD is 2/3 of AP. So if we, yes, Thelma.
Ma'am, would you say AD over AP equals 2/3?
Would you say,
Like
just say that
simpler.
again, Thelma, just say that again, Thelma, would you say?
AD over AP equals 2/3.
AD over AP equals 2/3. What you would do here, all right, is that you can cross multiply. So in other words, you can multiply this 3 at the bottom with the AD. So in other words, we can write this as 3AD is equal to 2AP. Does that make sense?
Oh, yes, ma'am. Yes, ma'am.
Okay,
Sorry.
so 3, no. It's perfect. All teachers ever want is for students to make an effort. Even if you get it wrong, it does not matter. Okay, the point is you're engaging and you're thinking, and that's perfect. All right, so 3 of AD, perfect. 3 of AD is 2. Yes. Is that you, Anza?
No,
Who is
it's
talking?
Nico.
Okay, sorry, go for
Nico.
it. Nico.
I wanted to ask, can we say
Yes.
that AD is 2 and DP is 1 because AD is 2/3? Like, we're going to use proportionality, saying AD is 2 and DP is 1. I'm not sure. Then the whole of AP is 3.
Yeah, I mean, look, we can definitely use proportionality intercept theorem because we have got parallel lines. But what they're telling us here is 3 of AD is equal to 2 of AP. So that's the whole thing. We can't write this as 3:2 because that wouldn't be true. That wouldn't be true at this stage. But we could definitely, I think you're right. I think we are going to end up working in this triangle over here. All right, so now that we've just unfolded this and we know what it means, that there's 3 of AD is equal to 2 of AP, let's just go and have a look at what they've given us over here. So 9 of DT, so that's this line over here, times DB is equal to 4 of PT times PC. So that's that entire line over there. All right. Let's just think about where we're going to start with this one. I wonder if we're going to work in that triangle. What have we already done? That's often a good place to start. So we've already proved that PA squared is equal to PC times PT. And we know that 3AD equals 2AP. So we know that that's true, and we know that PA squared is equal to PC times PT. So if that is true, then that means that we could make AP the subject of the form. Yeah, because look here, where we've got a bit of overlap here, Matrix, is this. We've got AP over here, and we've got PA over there, all right? So that's the same, okay? So let's start with this, and let's say that, so we've got that 3AD, I'm just writing it out again, is equal to 2PA. I'm just switching the letters around. So if we want to make PA the subject of the formula, we can divide both sides by 2, right? So that means that PA is going to be equal to 3 over 2 AD. We could then substitute that in place of PA squared, all right? So in other words, if we're working with the left-hand side over here, we could say that PA squared is equal to 3 over 2 AD squared. So that will leave us with 9 over 4 AD squared. Now, if we multiply through by 4, we would end up with 4PA squared equals 9 AD squared. And we know that PA squared is PC times PT. We know that PA squared, so that's this bit over here, PA squared is equal to PC times PT. All right, so I'm going to replace or substitute. So 4 PC times PT is equal to 9 AD squared. All right, so where are we now? Okay, we've got 4 PT times PC. All right, so we've got the right-hand side. Okay, we've got the right-hand side over there. All right, and 9 AD squared. So now what we need to do, does anybody know what we need to do now without me telling you? Do you know what the next step is? So the idea here is that when they ask us to prove that a left-hand side equals a right-hand side, the idea is try and work out what the one thing is equal to, and then try and work out what the other one is equal to. And if they can both be equal to the same thing, then we found the link between the two, right? So here, where I've got this 4PC times PT, I've got the right-hand side over here. Here, I've written it on the left. Okay, what I need to do now, Matrix, is I need to work with AD squared, and I need to somehow prove that AD squared is going to be equal to DT times DB. It's going to be equal to this. Right, so in other words, I want to show that this side over here, let me just highlight it for you, that side over there is equal to this over here. Right, because then if they're equal to the same thing, which is this 4 PT times PC, they're then going to be equal to one another. Okay, so 4 PT times PC is what links these two things together. So now, if we want to work out AD squared with DT and DB, we don't know which triangles we are working in. Right, so we're going to do what we were doing earlier with this PA squared equals PC times PT. All right, so I'm just going to go over to the side over here. All right, and then we're going to say rough work. Okay, so up at the top, so our rough work. Okay, because what we are required to show is that AD squared, so in other words, AD over something, right? And that has got to be equal to, from our question, let's just go back, dt times dB. So dt times dB. So now we go side to side or around the outside. So now if we go side to side, we have to say to ourselves, is ADB a triangle? Let's just go back and have a look. Is ADB a triangle? And as it turns out, yes, it is. ADB is a triangle. Is DAT a triangle? Yes, it is. Can you see that matrix? So now we know in which triangles we're going to work. So we're going to work in triangle ADT, and we're going to work in triangle BDA. All right, I'm going to highlight them for you so that you can see these triangles just to make it a little bit more obvious. Okay, so ADT, let's get rid of all these other marks on the page. Okay, ADT is here. Come on. So this is ADT. All right, so that's triangle ADT, yes.
Can I just ask that last statement that you put in under 4a, your 4pa squared equals 9ad squared, the one underneath it, where did you get that statement from?
Okay, I'm going to go with no problem. I'll happily explain that again.
Okay.
So I'm just highlighting this, Kayla. All right, so just tell me, which one did you want me to explain again for you, Kayla?
The last statement, the 4pc times pt equals 9ad squared.
Where did I get that from?
Yes, ma'am.
Okay, so a lot of this involves substitution, Kayla. All right, so in the beginning, when I was looking at the information that I had, I know from what they told me that 3AD was equal to 2AP, and that PA squared was equal to PC times PT, right? So now I highlighted that. Maybe it would be easier if let's just, and PA squared was equal to PC times PT. Okay, so the link between these two is here. Okay, both have got an AP in them. So that's why there's no sort of obvious place where to start with this question. So that's why I thought, well, if I've got a PA in the one and a PA in the other, maybe I must rearrange, make PA the subject of the formula and go ahead and go and sub that in, which is what I did. Then when I got down here, Kayla, all I did was go back and say PA squared is PC times PT. Okay, so remember PA squared up here, where I've just put the star now, PA squared is PC times PT. So I just substituted down at the bottom. I replaced the PA squared, which I've highlighted in orange, with PC times PT. Does that make sense to you?
Yes, ma'am. I see it now.
You can see that. Okay, so it comes from here. I'll connect the two with this orange line. Okay, that's where it's coming from.
Thank you, ma'am.
No problem. And now that I can see that in my answer, I've got AD squared is equal to 4PC times PT. I can see that this 4PC times PT is the link between the left-hand side and the right-hand side. So that's why I'm now trying to link together AD squared with what they gave me in the question, which was DT and DB. All right, now I know which triangles I'm working in. I'm going to prove that they're similar, and then I'm going to be able to go from there. All right, so now let's go back and go and have a look at these triangles, and let's see what we already know. Okay, so remember, PA is a tangent. So, okay, well, the first thing that I think that we can see here, that's the most obvious, can you guys see this? Angle D1 is common. So let's start there. Angle D1.
Would you make that?
Common. I beg your pardon?
I have one.
Why throw another taxi?
Because it's working.
Maybe that's a mistake. Okay. Now we can see the D1 is in both. What else have we got?
Ma'am, isn't A1 equals to T4? No, never mind.
Yeah, it is. A1 is equal to T4, but unfortunately T4 is not inside the triangle. So A1 is equal to... A1 is also equal to B2. There we go. That's it. Right. So A1 over here, can you see that matrix? A1 over here, so the angle between the tangent and the chord. So the tangent is PA, the chord is AT. So if you put your fingers at A and T, follow that to the circle at B to B2. Can you see that? Okay, so A1 equals B2 because of tan chord theorem. Which means that, all right, angle ADT has to be equal to angle DAB. Okay, because of angle sum in triangle or remaining angles of the triangle, angle sum in triangle. There we go. All right, so this means that triangle ADT, now the order is really important, is similar to triangle. Let's make sure that we've got A, D. Now, why do we have two D's here? D is common. B, D, A. Have I done that right? T1. Oh, hang on, it's angle T. Oh, so this is, okay, that's T1 over there. Oh, okay, all right. Sorry, I wrote the wrong thing here, beg your pardon. All right, it's angle T1 is what it's called. Okay, so angle T1, I called it A. I put the cup here on the wrong thing. Okay, so T1 is going to be equal to angle DAB. Okay, so that part was right. So DAB is correct. Okay, so triangle ADT is similar to triangle BDA. Angle, angle, angle. Okay, and now matrix. We can go ahead. Remember, this is the part where we have to write down first two over first two is second two over second two is first and last over first and last. All right, so now that we've got the order correct, we can say that AD over BD is equal to DT over DA is equal to AT over BA. Corresponding sides in proportion. Okay. So now, remember guys, we wanted dt, let's just go back to our question again. Sorry, if we were working on a board in a classroom, it would be a little bit easier to go backwards and forwards. We wanted dt and db. dt and db. Okay, so dt and db, there's dt, there's db, all right? And we wanted dA squared. Oh, beautiful. See, look how nicely this is working out. And here's our AD squared. There we go, AD and dA over there. All right, so now that we can see that AD squared, so I've cross-multiplied, I'm working with these two over here, so AD squared is equal to dt times dB. Okay, we're nearly there. This is the last step. Okay, so remember, all right, back here, but 9AD squared was equal to 4 times PT times PC. So that means that 9 dt times dB, so I'm substituting now, dB is going to be equal to 4 PT times PC. Okay, so I've substituted here matrix. All right, so if you're getting lost there, this AD squared here, remember it's equal to dt times dB. So I've just done a direct substitution. Okay. How does that feel? Cool, Neo. I'm so glad. That's amazing. Wonderful. So glad it makes sense.
It does make sense, but it's really long.
It's really long, isn't it? Okay, absolutely. No,
Can you
this
tell me
is
the allocated marks.
I beg your pardon?
The marks. How many marks do we get for?
Something like that would probably be out of 5 marks. So this is proper difficult problem solving. Okay, proper difficult problem solving. All right, so if it doesn't make 100% sense to you, it's not the end of the world. What is important here, Matrix, is can you do the first questions? If you can do question A and question B, if you can't do question C and it doesn't make an awful lot of sense to you, it's not the end of the world. That is not where you're going to get the majority of your marks. All right, so remember this is an advanced class, so we're specifically focusing on these difficult questions, but I promise you the more you practice this, the easier it will get. Okay. All right, let's go and have a look at another one. All right, and that's going to be the last one that we're going to be able to do this evening. Okay, so the other question is here. Hopefully this is big enough and everybody can see it okay. All right, so they've told us that A, B, and C are concyclic. That just means that they lie on the circle or on a circle, on the same circle. BA produced, so in other words, BA has been extended, meets the tangent through C at P. Not a very nice way of saying that, but in other words, what they're trying to tell us in this particular case is that PC is a tangent, okay, to the circle. Right? Doesn't make an awful lot of sense. The minute we see the words that PC is a tangent, what do we start thinking about?
Tan-chord theorem.
Tan-chord theorem, quite right. Okay, so tan-chord theorem has got to come into this. Okay, BC is produced to Q, okay, so it's extended to Q, so that PQ, all right, so this side over here is equal to PC. All right, well, if PQ equals PC, the other thing that means is that angle C4 and angle Q, the whole of angle Q, also have to be equal to one another, okay, because they would be angles opposite equal sides. The other thing that we also know from this diagram is that PC is a tangent. So that means that angle C3, which is the angle between the tangent and the chord being AC, is going to be equal to the angle in the alternate segment. So that would be equal to B over there. Now, the first thing that they want us to do here, and I chose this question on purpose because they want us to prove ACQP is cyclic. So I'm really glad that we got an opportunity to do this, because I know that this is something that a lot of grade 11s, when they do it, and matrics always struggle with. Okay, so we need to prove that ACQP is cyclic. So again, let's go and highlight it so that it sticks out for us. Here it is. And I don't know about you guys, but the first thing that I notice is that there's a bow tie inside. So if there's a bow tie inside, I'm starting to think converse angles in the same segment. All right. But it could be that, or it could not be. We'll have to just wait and see. All right. So what do we know, matrix? Well, we know that angle C3 is equal to angle B. Is there any way that we could prove that angle Q was equal to angle B? What do you guys think? What can anybody see anything that I can't see?
Yeah, I'm a bozo. Me, I'm a bozo.
Ma'am, would it be ambitious of me to look at a converse and somehow look at angle A2 being equal to P2 because of angles in the same segment?
Just say that again, Coco. Sorry, I was busy working stuff out here.
Correct?
Yes.
And if we are trying to prove that something is cyclic, we normally have 3 ways to do it. Correct?
Yeah.
And one of them would be angles in the same segment.
It would be converse angles in the same segment.
Converse
Absolutely.
angles in the same segment.
Absolutely. So it seems
would I then be
likely
able
here.
to say that A2 is equal to P2?
So you said that A. Okay, but how do you know that A2 and P2 are equal to one another? You see, this is the thing. Now,
okay, I'll rethink. I'm thinking.
Okay, that's fine. All right, so it might be that, but just looking at what we've got here, I don't think that we've got enough information to be able to work with converse angles in the same segment. So it might be one of the others. Let's just see what else we've got going on here. We have got an exterior angle of the triangle. So earlier when you were talking, I was saying, well, angle C4 over here is vertically opposite this angle over here. And that angle over there, R, is equal to this one over here. Oh, there we go. Can you see that now?
Yes, ma'am.
Okay, so what's going to happen here, matrix? Okay, so for AC QP to be cyclic, Q1 plus Q2 equals C4, angles opposite equal sides. C4 equals C1, vertically opposite angles. C1 equals A1, tan chord theorem. Therefore, A1 equals Q1 plus Q2, and that's what makes ACQP cyclic. All right, so I'm going to put that down. All right, so part A, we've got Q1 plus Q2 equals C4. Angles opposite equal sides. All right, then we said C4 is vertically opposite C1. C1 is equal to A1 because of tan chord theorem. And thus, QA1 is equal to Q1 plus Q2. And that is the reason why ACQP is cyclic. So therefore, ACQP is cyclic. Okay, and then the reason here is converse, exterior angle of cyclic chord. So we've managed to prove that it's cyclic. Okay, Canisilia, I lost you. Oh, I'm sorry. Canisilia, where did I lose you?
Oh, ma'am, never mind, I'm back.
Are you sure you're back? Okay.
Yes, ma'am. Yes, ma'am.
Okay. All right, no problem. Now they want us to prove that PQ squared equals PA times PB. So this is very similar to what we were just doing in the previous question. In fact, in the previous question, we did this twice. Do you think you guys can do this without my help? Or do you want us to do it together?
Ma'am, I kind of feel like we should do it together.
Okay, all right, Sinisiko. So in order to get PQ squared, this is where we need to write down that we're going to do rough work. Okay, because we don't know which triangles we're working in. So to get PQ squared, we've got to have PQ at the top in one and PQ at the bottom in the other fraction to get PQ squared. Then we're going to pop PA over here and we're going to pop PB over there. And now we're going to go side to side. Okay, and we're going to say to ourselves, is PQB a triangle? PQB, yes, PQB is a triangle. Now side to side over here. Is PAQ a triangle? PAQ, yes. Right, so let's highlight those. All right, and now we know in which triangles to work. So that worked out nicely for us. All right, so first of all, it was PBQ, which is this triangle over here, the big one. That's PDQ. And PAQ is this little one over here. Okay, so now that we've identified this, we are ready to write down in triangle PBQ. PBQ and triangle PAQ. Triangle PAQ. All right. Number one, do we have a common angle?
Yes, ma'am. P.
P, absolutely. Okay, so P is common. I quite agree. So let's start there. P is a common angle. Okay, so that's one angle that we've got. Now, this is probably not going to be obvious. Okay, so we've got angle P is common. So what does that leave us with? What I'm going to do, I'm just going to rub all of that out and then I'm just going to highlight this again. Okay, so this triangle over here. And then the big one. Okay, so in the little orange triangle, we've already taken care of angle P. We've done that, right? So in the little orange triangle, we've got angle A3 that's left over, and we've got angle Q1 that's left over. All right, so I suppose we can pick either one of these. Let's try Q1. What is Q1 equal to? Q1 would be equal to, because remember this is cyclic, right? So Q1 would be equal to C3. Does that make sense to everybody? Because they're angles in the same segment. I'm just doing a little bit of rough work here. Okay, so Q1 and C3 are equal to one another. C3 is equal to B.
B.
Okay, because of tan chord. Okay, so that means that angle Q1 and B are going to be equal to one another. Does that make sense to everybody?
Yes, ma'am.
Awesome. Okay, so now down here, angle Q1, we said was equal to C3 because they are angles in the same segment. Now that we have proved ACQP cyclic. Then we're going to deduce, actually it's not a therefore, it's, and we know that C3 is equal to B because of tan chord theorem. So that means, matrix, that Q1 has to be equal to B. All right, so now we've got Q1 equals B. So now we can do the remaining angles of the triangle, which means that angle A3 is common. Q1 equals B. And then that means that A3, which is the remaining angle in triangle PAQ, has to be equal to angle Q in triangle PBQ. So A3 would have to be equal to Q1 plus Q2. Okay, angle sum and triangle. Okay, so that means for us that triangle PQA is similar to triangle PBQ, PBQ, PBQ. Perfect. Angle, angle, angle. Okay. Now that we've done that, okay, we're going to write the corresponding sides that are in proportion. All right, so we're nearly there. Okay, so PQ, first 2 over first 2, PB, is equal to second 2 over second 2, QA over BQ, is equal to first and last, PA over first and last, PQ. All right, and because we wanted PQ squared, there's PQ there, there's PQ there, and then it was equal to that. All right, so now we can cross multiply. So that means that PQ squared was equal to PA times PB. All right, so we've got that. Everybody happy? Thelma, great. All right. I don't know if we're going to be able to do this last question, which is really what I wanted us to be able to do. But at least we might be able to do question C3. Question C, what am I talking about? Okay, so question C, PQ is a tangent to circle ABQ. So we've actually looked at something very similar to that in the previous thing. They often ask that. Okay, so PQ is this line over here. All right, so let's just rub all of this stuff out. Okay, so here is PQ. All right, there's PQ over there. So just highlighted it in yellow. PQ is over there. And we want to prove that it is a tangent to circle ABQ. All right, so ABQ is somewhere over here. All right, so ABQ, a very bad circle. That looks like an egg, doesn't it? Goodness me. All right, so they're saying triangle ABQ. All right, so if that is indeed the truth, all right, Kayla, you were very good at this the last time. All right, you were able to find the angle between the would-be tangent and the chord. So which angles do we need to prove are equal, Matrix? Can the rest of you see it? Remember, PQ would be the tangent. Okay, so if PQ is the tangent to the circle, the angle between the would-be tangent PQ and the chord AQ is angle Q1. Q1, okay? So now put your finger at A and put your finger at Q, and now follow A to B and Q to B. Can you see that? So it would be equal to angle B, which would be the angle in the alternate segment. So if we can prove that Q1 equals B, then we've proved that PQ is a tangent. Okay. All right. Now, have we already proved that Q1 is equal to B? Oh, we have. Look here. Right, we've already shown that Q1 was equal to B. So this is actually not a particularly difficult question once we have identified the two angles that we need to prove are equal to one another. All right, so in part C, this is what we would do. We would then say that angle Q1 equals angle B. Okay, so this was proved above. And therefore, PQ is a tangent. And our reason here, converse, tan, chord, theorem. Oh, it's a pleasure, Nakutaba. So glad you enjoyed it. No problem. Bye. And that's it. We're done, guys. Okay.
I won't lie, Lee, that was a lot to take in, hey? But
that was a lot, wasn't it?
It was good, but it was a lot to take in.
Okay.
How is the rest of us feeling? Can I get a thumbs up? Nah, it was okay. It was good. How are we feeling about these kind of questions? I'm seeing 2 thumbs up. And Thelma says also a thumbs up. Tanduleti says 6 out of 10. Bonolo is crying. Oh my goodness. Just a bag of feels. Itimeleng says, okay, I've got a hectic and a 50-50. Yeah, guys, we're not gonna like it's hectic, but these kind of questions, literally, they take practice and looking at things. And I really think Lee's strategies on how to solve these are really going to help you guys, which is going to yeah, it's kind of like a segue into what I need to say next. Lee, is there anything else you need to add, or are we all good?
No, there's nothing else that, I mean, you know, I would obviously, I mean, I'm sure the matrics are tired now as well, but you must just keep practicing. Okay, and then of course come to Watobe and come and do maths with us, and hopefully we can help you as much as possible make all the stuff that's really difficult. Maths isn't that bad after all. Safiso, you have made my night. That's wonderful. Thanks, Safiso. I really love your attitude. That's brilliant. Okay, all right. Well, Matrix, we'll see you again next week in the holidays if you're going to join us for Holiday Club. Yes.
Bye, ma'am.
Bye.
Ma'am?
Yes, did you want to ask a question, Sinisipa? Sorry. Go for it.
For the first lesson, right, I went to after the first lesson, I went to the Watobe link, right, to check the quiz, right? So as I entered there, I can't find the quiz. It doesn't show up. So
yeah, my apologies about that, guys. I've just been told that there shouldn't have been a quiz this week. So I don't think there is a quiz, but Michelle did tell us that she found it on the 6 o'clock link. So have a look there. But as far as I've been told, there shouldn't be a quiz at all today. I'd found this out while we were doing the second class. I'm very sorry about that. But I don't think there is a quiz. But if you do find one, please do WhatsApp us on our line and let us know that there is one so that they can okay, ma'am. Thanks. Yeah, Bianca says she did it from the 5 o'clock link, so I'm not all too sure either what's going on. But I will speak to IT and we'll find an answer for you guys. Please don't worry about that. Yeah, with that being said, guys, we really do hope you join us for Holiday Club. Lee is going to be teaching both you guys and the grade 11s problem-solving techniques. So there won't be anything in particular any subject in particular you'll be looking at, like geometry or circle geometry or anything like that.
Yeah, we'll have to look at circle geometry because that's what those matrics have done as well. So
the grade 11s have done
as well.
Those
grade 11s have done as well. Sorry, my brain is fried now as well.
Yeah, can you feel it? That's exactly what the Holiday Club is about. The grade 11s and 12s, you guys will all be together and Lee will be teaching you guys problem solving skills. So it will be things similar to this, but ways and strategies on how to solve them and such. So if you want to learn more about that, please do join us for next week's classes.
Absolutely.
I think the link should be going out tomorrow.
Yeah. So yeah, perfect. So Bonolo, the next lesson, this course is now finished. So as Coco was saying, the next lesson will be the Holiday Club, and then we will start up the matric lessons again next term, and we'll start with Treg. Okay, Bonolo?
Ma'am?
Yes, can you see there?
Sorry, I didn't catch when the Holiday Club will be, when it will be.
Okay, can you see it's next week? All right, so it will be at 5 o'clock on Tuesday and then again at 5 o'clock on Thursday.
Oh, okay.
Okay. It's a pleasure. Pleasure. See you then, okay?
Yes, ma'am.
Awesome. All right. Bye,
cheers.
everybody.
See you all, guys, all of you, or some of you next week if you are available.
See you next time.
We will be doing trade later. We'll get to it. Don't worry. We will get around to it. Okay.
Well done, Matrix. Bye.
Bye, everyone.